Hey everyone, welcome to our talk. I hope you're enjoying your time at GDC. My name is Eoin and I'm Tech Director from Black Shamrock, a virtual studio. Today I'll be telling you all about our experience using asset health metrics to optimize Voyagers of Nera, which was a co-dev collaboration between Virtuos and Treehouse Games. Virtuos is a large co-development and full development company with many studios across the world. We've worked on over 1,500 games, so we get exposed to a lot of projects, and we see the problems that developers are facing. We can confidently say that the accumulation of content optimization debt, or poor asset health, as I will refer to it, is a common issue. Voyagers of Nera is a multiplayer online co-op game. It's built using UE5 and uses the world partition system to give players a large open world on the open seas with lots of islands to explore. It also uses Nanite and Lumen, which can be pretty demanding on the GPU. We want to support a wide range of hardware and use a fairly low min spec to make the game really accessible. All these factors really emphasize the need to maintain good asset health.
Nera, our home, a place of endless beauty and wonder, now needs our protection. Awaken the spirit of your island. Grow together, then restore the balance of our world. Discover new horizons. Rise as guardians. And harness the world around you. Grow your island into your home. Nera is calling, and your voyage has just begun.
A quick word on our experience collaborating with Treehouse Games. In short, it was awesome. Co-dev is a partnership, and in this case, we had great partners. And I believe Treehouse Games would say the same about us. We worked together on multiple topics, as well as the asset health system. Virtuos implemented important gameplay features, such as the boat, and we also optimized the server using instance actors and masse. There is a video cast of us discussing our collaboration for those that are interested. And we got this great quote from Ryan. The talk today is broken down into 5 sections. We talk about how we want to transform asset health on all of our projects. We get into the Goliath asset health system, which is part of our Goliath optimization tool suite. We talk about building a better ship. This is a story of how we integrated these tools into Voyagers of Nera. We go over the results we got from using the system, and then we present our conclusion. We hope to change how developers approach optimization on their projects. We want to make game development easier for everyone and to automate the optimization process as much as possible. We want to empower developers to spend more time on creating assets while simultaneously optimizing content earlier. In short, we want to transform asset health. One of the most common problems I've seen on projects with performance issues is that they accrue unhealthy, unoptimized assets over the course of the project. So let's start by establishing some common issues we have all seen. I imagine everyone here has heard these questions before. The game needs to look good as a priority. Can we do an optimization pass later? Can't engineering just optimize the engine? How do we know which assets are the problem? But the most important question to ask is, when was the last time your project had an asset health check? Some projects literally don't have any until the very end of the project or due to some kind of an emergency. Let's talk about how asset health problems happen. In a perfectly functioning project where every asset is shippable, this is how the pipeline should work. The developers use the DCC pipelines to build assets that are imported into Unreal. The Unreal Engine applies the default for different asset types. At this point, assets are rarely healthy. They're usually configured for excessive MIPS, vertexes, lacking in the correct compression, loading, or streaming settings. Despite this, they can be placed directly into the game. We get to see our content come to life. An asset's healthy state is only achievable after refining the asset settings, which frequently relies on us placing in the game and understanding how it's going to be used. Unfortunately, this last step is skipped frequently, and once developers get their assets in the game, they fail to refine the asset settings to configure for optimal content. The main cause for this is time pressure, and a priority stack where this work is never at the top. There can also be cases where the budgets for the assets in game change over time, requiring subsequent refinement pass. This neglected work just compounds over the lifetime of the project and creates debt and undermines quality throughout development. The Goliath asset health philosophy we are pursuing is simple. Many asset health issues are easily solved once they're identified. Improving visibility will make optimization easier, and automating the process will deliver the best results with the least effort. Now, as simple as the philosophy is, it faces some challenges. Suboptimal content is hard to find. You can spend hours profiling or examining content asset by asset. In the late stages of a project, you can have accumulated a huge amount of art content optimization debt. At this point, it will take a lot of manpower to make things right. So we wanted to provide a solution that could cover every facet of the asset health problem. Total visibility using a web-based tool that anyone can access and see the current state of the asset health for the whole project. We want tracking over time to assess progression or regression when it comes to our asset health. We want a highly automated system with nightly reviews via CI/CD and quick fixes in the editor for its many asset rules. The result of these efforts is less manual work for the team and a higher quality game at all stages of development. We call our solution the Goliath Asset Health System. It's part of a suite of performance and optimization tools we have at Virtuos. We believe our system can make game development better and easier for everyone and improve product quality across the life cycle of the project. I want to take you through the four main components of our system. The front end is web-based for accessibility. It's built on top of Blazor and it's implemented using C#. These are highly flexible APIs that can be changed for every project's needs. This is very simple to deploy. We have installation scripts or GitLab pipelines you can integrate into your own environment. And it connects to the Unreal editor so that collections of assets that have failed the asset health check can be passed to the editor for developers to work on. The UE5 plugin is the workhorse of the asset health system. It's where the asset reviewing actually takes place. It's a rules-based assessment system and can be used as a validator on submission. This is configurable per project. It comes with many different asset rules covering things like vertex counts, text resolution and compression, loading, etc. And all of these can be configured to your project's needs. These rules are context aware. For example, rules for meshes are aware of every usage of a particular mesh in your game's assets. We will cover some of this later. The back end is responsible for managing and storing all of our asset review data. It's built on ASP.NET and it utilizes MongoDB. Its key responsibilities are handling API requests from the editor, the CI/CD pipeline, and the web front end. Finally, we have our automation. The Goliath Asset Health System can be fully automated for nightly asset health checks. We provide a commandlet that will generate a report on the asset health for every relevant asset in the project, and all the results are stored persistently on the back end. These nightly reports are the key to total visibility on your asset health status. Now we will tell the story of how we integrated this tech stack into the Voyagers of Nera project. We first began discussing the art content optimization just after closed beta. Player feedback on the closed beta was mostly positive, but performance was highlighted as an issue. Suboptimal asset health was a key contributor to performance issues. We worked with Treehouse Games for their early access release, where the performance has improved enormously. This collaboration made for a much smoother early access, and the game has a very positive Steam rating. Configuration is very easy, although it may take some experimentation and tweaking to configure some of the asset rules. Once the plugin is added to the project, you need to configure the plugin in the project settings. There's a lot of options here, so I'm just going to cover the important ones. The first important thing to set is your asset rule set class. This is a blueprint that will contain all of the asset rules and their configuration that you want to have in our project. You can actually configure several and use them for different scenarios where you need different sets of rules. Next in the plugin settings, you can add the blueprints and maps, which are the root content for your entire game. This essentially needs to be the content that makes its way into your cooked builds. It's useful in projects to only review the content that's actually in your game, as frequently content for prototyping will give you a lot of false positives. Lastly, we configure our web API and interface settings. This is what connects the editor plugin to the backend and front end respectively. Next, we need to configure the asset rule set class itself, which is a blueprint. Here we configure a list of asset rules specifically for our project. These are all defined in the plugin's code, and this is a forever growing library. You can see we're adding the rule check texture resolution budgets, which is a rule for texture assets. Here we have mesh category sizes and the maximum resolution we expect for meshes of this size. You can see here we have more tests configured below. I'll show you a quick list of them. Some of them we will discuss more in the results section, but if there are a few that are kind of interesting you and you want to ask questions, note them down for a Q&A session later. The web dashboard. This is the portal into our asset health data, where you can monitor our asset health metrics and track them over time. It's heavily customizable per project, but its base functionality is pretty useful. The dashboard view contains a bar graph for viewing the results over time. Bar graphs indicate the asset health metrics for each run. We have passes, failures, and warnings. We also have a list of rules that are matching the current query. These include details such as the rule name, asset path, asset type, and description. We can use the date range to focus our attention to any period of time which we need to do. And then we can highlight a specific day by clicking on a specific bar. This will auto-filter results for that date and result. Very conveniently, we can also quickly focus on the latest info from the last run. Additional filters can be applied for the rule name, the asset type, the path, etc. And one of the most powerful features is we can export that current list of asset rule results into a collection that will be created directly in the Unreal editor via deep linking. Similarly, any individual asset can be opened in the editor simply by clicking the button. So if you want to run the asset review tool on any asset or collection of assets directly in the editor yourself, you simply right-click and you hit Asset Review Tool plugin, Review Assets. This can also be run as part of the submission process. The asset review results are displayed in a window with two tabs. One of these is the Asset View tab, and the other one is the Rule View tab. They're the same results, but different ways to view them. As the name suggests, the Asset View tab focuses on the assets that were reviewed, and we can also review by asset type. Each rule and its result is displayed for the chosen asset, and the quick fix panel displays the full failure message and the quick fix message explaining what it will do to fix it. You can easily quick fix any asset from this panel. The Rule View tab allows the user to focus on test results by rule rather than by asset. It has a table that displays all of the rules that have been run and whether they passed or failed. You can now quick fix by rule, allowing you to quick fix assets en masse in large quantities. This is a very powerful feature. Each rule which is selected will display every asset and why it failed. As you can see, this is a really powerful tool that allows you to review and fix many assets in the editor. So for the Voyagers of Nera, we integrated the asset health system post-beta. So we had to use our workflow for addressing content optimization debt. The Goliath Asset Health System nightly review the content for the whole game, and they give us an up-to-date backlog. Using the dashboard, developers can investigate which rules have failed and why. The dashboard links directly into the editor, where developers can use the collection system to break the work down into chunks and share it among them. And then the asset review tool can be used on large batches to automatically optimize most assets. It's a good idea, of course, to review and test, possibly using the whitelisting feature or hand optimizing certain tricky content. The eventual result being that the asset health recovers, and we see all green bars in the Goliath Asset Health System dashboard. We can say conclusively that the Goliath Asset Health System works exceedingly well when used like this. We will share the results in the next section. Now I want to briefly talk about a different approach, the proactive workflow. Developers will build a new asset or update an existing asset. When they go to submit in the editor, the asset review tool runs as part of the validator framework in the Unreal editor. Any optimization issues are highlighted. Projects can be configured to allow or to block submission on the basis of whether this health check has been failed. But in most cases, the asset review tool can automatically fix the optimization issues, allowing the developer to submit. So the result is that your asset health remains good throughout the project. This proactive approach is very beneficial and a massive time saver. Of course, we still recommend you use the web dashboard to monitor the project health, particularly when any new rules are introduced or if budgets need to change. So now we're going to examine some of the results we had from using this tool. This was from our first pass where we fixed a lot of content. These are the results in terms of assets and their issues that were identified and fixed. Over 3,000 assets in total. Can you imagine trying to do this all by hand? As you can see, the majority of asset rules were quick fixed. Each of these rules improved the game's performance in a different way. I will explain how they worked. The texture resolution and Nanite static mesh triangle check had a positive effect on GPU memory. The blueprint for each loop rule reduced the CPU hitches. The world position offset and particle effect type rules also improved render times and GPU performance. Some rules were quite simple. The WPO distance check just examines the disabled distance on the static mesh components and blueprints, setting it to a pre-configured value. The Niagara effect type rules were also very simple. They made sure that every Niagara system had to be using a Niagara effect that was configured with the correct scalability settings. The Nanite mesh triangle percentage and texture resolution rules had a common mechanism. The mesh bounds were evaluated and the size category determined. The target triangle mesh count and maximum texture resolution were determined via a lookup table. Then the texture load bias and or Nanite mesh triangle percentage were adjusted accordingly. The blueprint for each loop rule is an important performance rule. When using a for each loop, pure functions attached to the array pin will be invoked on every iteration of the for loop. And so, if it's a large set of data or an expensive function, you will get hitches. There are multiple steps to making this rule work. The failing blueprints had to be fixed manually though. The asset rule checks all the blueprints, iterating over every event graph in the blueprint, and from the graph we can get all the macro functions. When we have all the macro nodes, we can check if they are for each loop, and from the for each loop, we check the array input bin to identify if it's invoking a pure function or not. These are the performance improvements we measured after our first large pass of content optimization. We measured this on the recommended spec for the game, but unfortunately the changes were not completely isolated, and so some other optimizations are also at play. But we can say with a very high level of confidence that the GPU performance and the memory improvements are a result of the content optimization, and some amount of the render thread improvement too. What we failed to capture and quantify though was the large reduction of hitches. And while I don't have any numbers for this, I can tell you it was indeed smooth sailing after our content optimization pass. So, to bring it all home, performance is an ongoing challenge and content optimization is frequently deprioritized. But what we've learned is if you assess your asset health metrics as part of your development process, you can get better outcomes across the board. So to put our conclusion in words, asset health is a cornerstone of game optimization. Enforcing good asset health practice is the most effective means of keeping your assets optimized. Automation is the shortest path to good asset health, and practicing the Goliath asset health philosophy will give your team more time back and a higher quality product. And now for the fun bit. We can have some Q&A. Any questions?
Can you place the slide back to the texture? How do you decide the texture size based on the...
Absolutely. There we go. This one saves a lot of GPU memory. And there's a lot of different ways you could do this. Like you could unwrap the UV space and calculate the texture density, but that takes a long time. And you're reviewing thousands or tens of thousands of assets in every pass. So you got to keep it light. But this works nearly as good. Hey, Toss.
Hey, thanks for the talk. It's awesome. First question I have is about who's authoring the quick fix, rules or actions to fix the assets?
Yep, great question. So we have a big collection of them, as you saw, and when we integrate it into a project, one of the first steps we have to do is get someone in tech art to come and collaborate with us to set the budgets. Now we have past projects we can reference, but it's usually going to be a little bit different depending on the project, right? Stylized art content is going to have a different kind of, vertex count budget than a super realistic game. So usually we'll end up iterating on it quite a bit. And it can take some time to get it right, particularly if you're planning to bulk fix it. It's not such a big deal if it needs a bit of refinement because it's giving you some false positives in terms of failures, right? But yeah, if you're going to bulk fix a lot of it, you will do a few iterations until it's 99.99% correct. And that's when you'll use the whitelisting feature for the things that aren't going to work with the budgets that we have, really tricky content, really thin fibrous meshes, for example. It's hard to give those an accurate, texture resolution budget. So the whitelisting feature exists specifically so you can eliminate them from the check. They are a little bit unmonitored then, but they can only be whitelisted per rule. So if you're selective with it and you don't let people put everything on the whitelist, it's usually fine.
I got one more. How many engine changes were required to Unreal to enable all of this?
No engine changes.
Great. Thank you.
You're welcome. That's important. It needs to be super portable. And obviously, if you keep it from requiring any engine changes, it's easier to bring it to the next version of Unreal where you might have some API changes and whatnot, but you don't have any actual engine integration to bring with you.
Yet again, thank you very much for the talk. It was really informative. I wanted to ask specifically about how you decided what the optimal texture size for the current object is. So do you base it per project on the largest mesh is using a tileable texture of X, or do you base it on textile density, or?
Yeah, I'm going to go back to a previous slide because it will help me explain this.
Yes, please.
In this particular case, each of those sizes, they're not configured here, but they have a global config elsewhere in the project settings, and they're not sorted by size here. So, don't freak out. But deco is the smallest one. So we use concepts rather than hard values, because what we do is we'll get the volume and we'll divide it by its shortest, axis. And this is a much better, size metric, if you will, than to use raw volume. So we have like approximate sizes for these things, like, you know, deco is less than 100 millimeter by 100 millimeter by 100 millimeter, and it would go all the way up to like giant is like essentially like 10 by 10 by 10 meters. So they're conceptual, and then we'll work with tech artists who are used to working in conceptual space to attach like MIP levels to it. And then we'd run some tests. And like through our testing, we may have to refine a few things. We may have to refine the sizes. We may have to refine the resolutions. But we get to a point where the idea is that if you were to increase the MIP size, it would give no visual improvement.
Okay.
Right. And it is determined by humans. There is a textile density view in Unreal that we also use frequently. So we'd check both of them. But yeah, the idea is this is as good as it can look. And if we increase it any more than that, like we get nothing back.
Okay, cool, cool. Yeah, I'm gonna ask another.
Thank you for the talk. I have also a question. Are you preventing artists to submit if something's wrong with what they did, and how you manage teaching what they can and what they can't before?
Yeah, it's a very good question. I think I might mention it 2 or 3 times. You can configure it to allow them to submit it or not. All right, so every project can pick the workflow that they want. And I did repeat it a few times because this is a controversial question. So we have had projects, not this one, where we did like basically enforce that it has to pass cleanly. But we have the concept of pass, fail, and warnings.
Yeah.
We moved quite a few things into the warning level, right? So that you could still submit if it wasn't perfect, but many things were still, you can't submit on failure. But virtually everything that you couldn't submit on failure, right? You could just hit the quick fix button. It fixes everything. And then you go to submit again and it just goes through validation. So at first there was like controversy. And then when everyone realized, well, hold on a minute, I actually just need to click a button and it gets fixed. We do like human beings to check these things, right? So you hit the quick fix button, you can take a look at the assets, see if it broke it or whatnot, and then submit. This is like a far smaller time cost than, say, having to try to figure out why everything is rendering like expensively or like using too much memory. So people adapted, and there were like occasions where people were confused about what had happened. But the significant majority of occasions was like, it was red and I hit a button, it became green. I got on with my day.
Okay. And I have another quick question. Are you using a prompt or dialogue when they did something that won't pass the validation
Yeah.
before? Yeah. Okay.
Yeah, so it was hard to bring every screen in because I thought I'd like run out of time. But like when you do the asset validation, what will come up? So like everyone would be familiar with the version control screen in Unreal. So you hit the submit button, and there is like a validation system in there already that we have built on. Many projects use the editor validators. So this will actually run when you hit the button. So it will warn you that like you didn't pass asset validation with like vanilla Unreal Engine like warning window. And then you'll hit a button and it will bring up this window. And this is the window that will tell you what went wrong. It's pretty clear cut, and then you can fix it and resubmit.
Okay. Thank you.
It's 5 minutes.
Do we have
You got 5.
Cool. So when you're clamping the texture sizes, are you doing that per texture group and different on different scalability settings, or are you setting directly per texture the?
Yeah, these are good questions. So we do have one test which checks that you are using the correct texture log grouping settings.
Yeah. Okay.
The texture log grouping settings, they will affect what gets baked,
Okay.
but they don't actually affect the MIP that's chosen at runtime. Okay, so you can use those to constrain to like a, say you never want to have more than 2K texture resolution for a particular group. That's cool. But then you might have multiple like assets of different sizes that are using textures in that group. And you will want some of them smaller than 2K. They might be 256. You can then use the LOD bias setting
Yes.
in the textures to knock it down. So you kind of use both of them together. But yeah, like that is one of, again, a very useful test or rule that we've used to make sure that you are using the correct texture log group settings. And in that rule, the important things we did was identifying like what were static world elements and what were skeletal meshes and characters, and identifying like what's basically UI. So like they all are, that's generally how the texture log groups work in Unreal, grouping them into assets of these types. Obviously there's a huge range of like different things that can be within those categories, but yeah, this was one of our rules to make sure that everything got into the correct texture log group.
Thank you very much.
You're welcome.
Can you go back to the slide where you have all the validations?
Yeah. There we go. There's the check static mesh log group one. And we had one that checked it per mesh size, because we ended up with like we had like a world static one and then giant world static one. It was extra special. Any more questions? No? Okay. Well, no, thank you guys very much.